Oh, looks like we went live a little bit earlier than expected. Apologies to that, folks. I didn't even notice. Apologies. Welcome to another talk. Apologies. We had such a long break. I was kind of getting used to just sitting here, but we're back and we are joined by a wonderful guest. It is, in fact, Erez Berkner, who's here to discuss the differences between monitoring Kubernetes and serverless based applications. I'm not going to waste any more time. Erez, take it away.
Excellent. Thank you very much, Darren. Glad to be with you here today. My name is Erez Berkner. I'm CEO and co-founder of Lumigo. And today we're going to discuss serverless and Kubernetes and how you're going to, what are the differences monitoring those. Let me share my screen first. I think the main point is I'm going to go through a couple of methods in my presentation and talk about the differences. I'm also going to show a live demo of how this can be done. Every one of the topics I'm going to discuss can be its own lecture. So I encourage you to take this as pointers and take it to the next level and search for each of the topics if you want to drill down further. At the same time, at any point, feel free to ask questions in the Q&A, and I will try to have like at least 5 minutes at the end for questions. And you also have my email over here, so feel free either to hit me on Twitter or send me an email, and would love to try and help with any questions or things you might have. With that in mind, I want to take a second to define what it is when I say serverless, because a lot of people consider serverless to be different things. I think early on in the past it was mainly functional as a service. AWS termed the coin functional as a service and serverless basically back in 2015 with the release of AWS Lambda. But ever since we really seen the transformation of more and more what I like to call managed services to fall under this umbrella of serverless. So I think we went from functional as a service to almost everything as a service. So yeah, it's Lambdas and functional as a service, but it's also messaging as a service like SQS and SNS and managed Kafka, for example, data as a service, DynamoDB, Snowflake, storage as a service, container as a service, Stripe for payment as a service, Twilio for messaging. All of this is what falls under my definition of serverless. And I'm not religious about it, but just for the sake of this discussion, it's important because when you're working with managed services, with things that you don't deploy a server, that you just consume them via APIs, that really changed things in monitoring in the way I think you should care about. And that's the base of the discussion. And that's where serverless is today. So I think Kubernetes is fairly simple, and everybody knows Kubernetes is containers and how this works. This is, for this discussion, is what I mean serverless. And we see today a lot of companies using more and more managed services in the middle, event-driven architectures, a Lambda writing something to DynamoDB, triggering a Lambda, and those are the serverless applications that I'm talking about. With that in mind, what are the challenges of monitoring those environments? So whether it's serverless or containers, Kubernetes, I think the main point is we're no longer in the three-tier application architecture. We're dealing with distributed architecture when you have dozens or hundreds of ever-changing services. A lot of them are out of your control. And when something goes wrong, it's very hard to understand what's going on, to zoom out and have the overall view of your application, understand if this is critical or not. And for that, you really need to have like the connections between the services, understand what happened. And this is where distributed tracing comes to save us. So distributed tracing is the idea of we want to move from this, a bunch of services where one of them goes wrong, but we don't really know how they connect in that specific transaction that went wrong to this, to an order where I can understand what went wrong, but immediately I can go upstream and go service by service up until the customer-facing API, and then decide, one, what is the priority, who is the customer that's experiencing that issue, and then I can actually drill down to the request and the data and the inputs and outputs and see the details. So that's what distributed tracing is, and that's, I think, probably it's becoming clearer why this is important now. And the now is when we're talking about distributed system, about serverless, about Kubernetes, about managed services, because it's no longer a monolith. Monolith would make this much easier. We have, stack trace, and that's a good place to start. I think it's the other point is that one of the things that we are now seeing in the monitoring realm, and this is for Kubernetes and for serverless, is that it's no longer the classical separation that we've seen ops versus dev. In the past, ops would monitor, the health of the application, CPU, temperature, things like that. And when something goes wrong, if they can't fix it, they will move it to the dev, and they were like siloed and disconnected. When we're talking about the modern application, it's no longer like that. Like ops that we have been using one tool and dev as another tool are merged into a DevOps. Sometimes it's actually the devs that are doing also ops work. And I think one of the challenges is that there are still two different tools, one doing the monitoring, one doing the actual root cause analysis and debugging. And in the modern environment, in the tools that were released in the last couple of years, we see more and more tools that actually add the two. You monitor, you get an alert, you click, you start a debugging session, you understand what happened, you fix it. No longer going across tools because it's the same person many times. So I think that regardless of Kubernetes or serverless, you should aspire to have like a single tool for the entire flow. It really, really saves time. So let's talk a bit about Kubernetes. I think, I don't need to tell you how hot Kubernetes is. Everybody's either doing it or talking about it. And I think that when we think about monitoring, we need to pay attention to the 5 different layers, and we need to make sure we have monitoring capabilities for each of them. One is the infrastructure, that's hardware. Again, whether it's our hardware or is it cloud provider hardware, we need to make sure that whoever owns the hardware is monitoring that. The Kubernetes cluster health itself, the pod health and its status, the readiness, availability of the actual pod, and the application logs. All of these are different levels that each of them can, be either failing, alerting, or blocked. And we need to make sure that we have good health metrics and good alerts around all of this. So let's talk about some of the best practices. Prometheus goes very, very well with Kubernetes. I'm sure most of you know that. They integrate very nicely. Prometheus is an open source that you can use. And when monitoring, you want to look at, first and foremost, we talked about the alerts, about metrics. So you have like great plugins and agents for Kubernetes by Prometheus, and you can use those to pull metrics out of the Kubernetes nodes, and from there, write it to some persistent data store, whatever you choose, ship the alerts through your, your selected notification channel, and visualize them using Grafana. That's a very common model that if you're haven't checked this out yet, that would probably be my go-to solution when monitoring Kubernetes today. And that's great because it already provides you a lot of what you need, and you have like for example the cluster capacity, and we talked about the different parts, the hardware, the pods, the availability, the readiness. So this is with regards to the health dashboard and the metrics. When it comes to logs, then also there are best practices over here. Most of you probably know the elk stack, and if not, that again should be like the go-to simple solution, at least at the beginning, where you have everything like forwarded through Logstash to Elasticsearch and viewed with Kibana, and this allows you very strong abilities for searching. And one of the things that you need to remember is to make sure you're able to correlate everything. So we'll get to that in a second, but having a way to figure out a correlation ID within the logs and then searching them in Elasticsearch, that's important for distributed environments. Traffic monitoring, this is a great tool I really like. It's an open source visceral, and it visualizes the actual traffic between the different services. So this is probably a bit less known, but it's a really nice tool to have in a visualization that really can show you how things are moving in a visual way, and very easy to understand in bigger maps where is my problem. What about service mesh of its different implementations? So service mesh really makes things simpler when it comes to having the right checkpoints in place to understand what goes into the different services, what is the actual data going, and integrating, for example, a tracing mechanism. I'm not going to go into service mesh in this presentation. I just wanted to have one slide over here explaining that service mesh should have its own tracing and logging infrastructure. Like, you should use the service mesh infrastructure because it's much more powerful than anything that you will be able to implement without a service mesh. But just because you have the centralized control of all the communication. And with that in mind, I want to move to serverless. So serverless is, I want to call it the next generation, but it's actually parallel to Kubernetes and containers and microservices implementation in general. And I think serverless is really different in the sense that while in any implementation, let it be containers, let it be VMs, or even on-premise, you control your server. It can be a virtual server, it can be a physical server, but you still have the ability to deploy agents. You still have the ability to write code, to change code. Serverless really takes that away, because let's look at managed services, S3. You cannot deploy an agent on S3 or DynamoDB. You cannot write code over there. You cannot change the API. It's out of your control. And that's a real obstacle for all the modern like observability system. From metrics to logging to tracing, you're basically relying on what the service owner allow you to have. So if I want to visualize this, I think that one of the biggest problem is the distributed tracing. We showed that in the beginning. We want to have an end-to-end view of the entire application, but at the same time, if we use naive or standard methods, using correlation ID, using open source tools, or using agents, like most of the world is doing today, we'll have this gaps or this walls in the middle, because I can get the correlation ID from one Lambda to another, from one container to another, because I can pass it as part of the API of the HTTP request, for example, but I cannot get this across S3 or DynamoDB or others because I don't control that. So all the main tools, and I'm going to talk about tools in a second, have gaps over here. So it really breaks a transaction from one big transaction into 5 or 10 different uncorrelated transactions, which really takes the edge off distributed tracing. So with that in mind, what can you do? So there are different ways you can implement things that will allow you to still have the distributed tracing when it is across managed services. So the simplest, let's call it, or the manual would be to figure out a way to pass a correlation ID, let's say across DynamoDB. I must say I don't like it. It's not nice, but you can always, write this as part of your database or the record. I'm saying that it's not nice because I think all of us understand we don't want to pollute the database with some session ID. But at the same time, this is, if you're implementing this yourself, it's the best or only way that you have to do it today. The other is to use third-party applications, and there are few companies, mainly companies that started in the recent years, that actually tackling this problem. That's one of the problems that Lumigo tackles, focuses on. The idea is, again, how do we get across this? How do we identify that this compute and this compute with the S3 in the middle that triggers this Lambda, how do we understand that this is the same request without ability to deploy agents, code, and the ability to pass something through API because we cannot change the API. So I call it agentless observability, and I'll give a couple of examples a bit later. To summarize the monitoring, I think the different things, some things that to highlight. One, we're talking about Kubernetes and specifically containers versus serverless. Distributed tracing is a must as long as you have like more than few thousand requests every minute. If you have less, by the way, if you have just a couple of requests a second, you can probably get around with logs and timestamps, because then you can check timestamps and you would be able to figure out what's going on. You don't really need to correlate. But when we go more than 1-2 requests per second, that's becoming a real challenge, and with our environment today, with millions of requests per hour, and that's where it becomes really challenging. So in those, you need to have distributed tracing. In the container world, this can be agent-based, code-based, whatever you decide, either manual or through different tools. I want to mention here again, you can implement this your own. It becomes a bit challenging when you want to. When you want to maintain this, because then on every new service you need to make sure that somebody passes the correlation ID, and they never do. So we need to review what they're doing, and it's hard to do that, especially when it's more than just like a couple of people handling the application. But you can get things like OpenTelemetry, Jaeger, things like that from the community, open sources that can really do great job. And OpenTelemetry becomes almost a standard. It will be a standard soon in distributed tracing. So I really encourage you to look at that and try not to implement that on your own. In serverless, either get it through the data or use modern tooling for that. We talked about that. In terms of cost and monitoring of the cost, you need to monitor resources in the containers environment as usual. I wrote it here because in serverless things are really different. You can actually put a price tag on a request very precisely, it's really going to change the way we think about costs in our cloud environment. Because think about a service application. I have an API gateway, triggering a Lambda, writing something to SNS, triggering a Lambda, writing something to S3. I can actually put a price tag if I know, the time they run, the memory, etc. I can tell you exactly how much did that cost. And it's very different than just having a container or VM that's running all the time. So that allows me to be very precise, and you can aspire for that. You can build your own calculators, or you can use tools that have calculators to show you how much that request costs. And then it's great for forecasting, for identifying bottlenecks, for cost optimizations. I think that that's going to be very, very big in the coming years. We talked about what to monitor. We talked about the layers of Kubernetes. I think on serverless, I write application only because you don't need to monitor hardware, the operating system, pods, etc. I would add that all application and also include failures reported by the cloud, for example. So if Lambda fails due to timeout, I consider this part of your application, not infrastructure. So it's much easier, but you need to remember that you still need to have the right monitoring in place. Nobody's going to monitor that for you, not the cloud provider. Nobody's going to fix anything for you. Nobody's going to call you when something fails. So it's still, even though it's managed, it's your responsibility. Service discovery is really interesting. There are different tools for service discovery for, I think, 30 years based on network. But in serverless environment, in managed service environment, we can do everything by API or libraries. So we're able to understand what's going on, not by sniffing traffic, it's by communicating with cloud providers and getting a view of what's going on in the relationship. So that's going to open a whole new domain of service discovery that we're going to see. And we talked about the monitoring ownership. That's still you. Let's not get confused. I think that I actually want to jump over this just because I think we talked about the challenges. I want to jump into showing an example of how a distributed tracing tool, observability tool, can look like when dealing with managed application, with containers, distributed tracing done, let's say, in a modern way. I'm showing our tool Lumigo. I want to show this not just for you to get impression of Lumigo, but even if you're implementing this on your own, even if you're implementing this based on open telemetry, that's absolutely fine. There are huge companies doing that. This is what you should aspire. I hear a lot of time, we didn't know that we can have this. So what I'm showing here is something that you can plan for, even if you're implementing that yourself. So let me share with you a quick demo. I want to start by saying in a managed environment, it's very easy to connect. So I'm going to show you Lumigo dashboard, but that's basically 5 minutes after we try to connect to Lumigo. It's basically based on IAM role, and once we get permission from the CloudFormation, deploying only IAM role, we use APIs in order to connect to the environment and show what I'm going to show here. So no agent deployment, no manual code, no changes to the data. That's all automatic. Two things I want to show here. First of all, in terms of monitoring, these are new things that we need to monitor. It's no longer about CPU and the temperature and those, especially in a managed environment. It's about invocations and failures. It's about call starts. It's about service latencies to understand where are my bottlenecks, function duration, cost, runaway cost, timeouts. So and a lot of application level metrics. So some of you are more of an expert to those environments and can really build that on your own. But one of the things that you need to do is to figure out what are the things that you need to monitor when going to those environments and what are alerts do you need to bake in. Whatever you use, make sure you're covering the right alerts. In Lumigo, for example, you get out of the box a lot of alerts about, if you have DynamoDB, so it's about like a number of reads, number of writes, spikes over there, etc., etc. And so when something goes wrong, you'll get an alert to PagerDuty, to Slack, to whatever it is that you're using, or Teams or that. And let's look at the issues page for a second and choose one specific failure that happens in the last time 19 minutes ago. By the way, this is a rideshare application that is actually running on AWS. It's our demo. So we connected this on top, so it's very easy to connect. And now when I want to drill down, this is where I mentioned moving from monitoring to debugging. So this is what happened. We saw like rise in the number of issues. And now when we want to understand what happened and find the root cause, we can actually see one by one each invocation of this Lambda that failed. Some had cold starts, we can see. And we can see over time, that there was a deployment actually over here, and we can actually see what happened. We can see code changes if there are. We can see what changed in the deployment. But when we really want to drill down, we'll choose one of the failed invocation, click on it, and this is where we move to the actual root cause analysis and the distributed tracing. So we'll ask to see the entire transaction end to end. And this is the heart of what you should have in a general microservice environment. Again, serverless or Kubernetes. So what do we see over here? First of all, this is why we got here. This post to social failed, as you saw. We can see this is triggered from Event Bridge. It's a managed event bus. Lambda triggering that, and this is a customer-facing API. Upright, it's a ride-sharing app. That's business critical. I need to get this fixed. P1, that's a priority. What do I do from here? First and foremost, I can see that there is another failure here in DynamoDB. So just by that, maybe there's two are related. And think about the power of seeing that together versus just looking at the logs. This really explains, I think, why you should aspire to get a visual view of that transaction, because in a second you will say, oh wow, there's like another, maybe you should, let's check what's going on over here with this DynamoDB. At the same time, we have a lot, we talked about Elastic and logging. So the biggest problem I think with logging today is that you have so many logs. How do we make sense of them all? And correlating the logs is very important. So either you get a correlation ID through the logs and search. Distributed tracing tool, modern tool, actually allow you to filter just the 35 logs that are related to this transaction, and you can read it like a story over here, like what were the actual one by one logs across all the different services that we saw. And I think the heart of this is a debugging part, post-mortem debugging. So for every service, you can click on it, and Lumigo is able to get a lot of information that doesn't exist anywhere else, from the specific exception and the stack trace and the exception variables when the exception happened, all the way through the event that triggered the Lambda, the environment variables at the time it ran, and the actual logs of this Lambda. These are things that we gather from a Lambda layer, for example, from running within the Lambda or the container, and available for you, again, without any code changes that you need to do. So just to real quick look at what we have over here, you can see like details.writeID cannot be an empty string. That's exception. If we look at the event that triggered the Lambda, you can see that details write ID is indeed empty. So just by having that in place takes all, now I would I would think about looking at the code of the Lambda, but just by saying this, write ID is empty in the input, that tells me don't spend your time on this Lambda, go upstream. Try to understand why is this empty. So I can go to any service, this is an event bridge, and I can see what was written to event bridge. And I can see the message, details write ID is empty as well, makes sense. Let's go one level upper. I can go one by one, including DynamoDB, for example, and I can see there's like a request going to DynamoDB that failed, provided key element doesn't match the scheme. I think I'm going to stop over here because I don't want to make this debugging session, but this is a way you can maneuver and go across any service, including external services like Twilio, for example, where you can see what was a SMS that was sent and so on and so forth. That's a level of tracing and correlation that you should have across managed services in order to be able to really control and understand what's going on in your production environment, because when something goes wrong, you really need to get back to business as usual as soon as possible. Last thing I want to show here is other part that not just about the correlation, but about latency. Latencies are a very critical and very common in microservices, because one service hiccup, let's say Twilio hicks up, it's not your fault, but that will slow down your application. And understanding the hiccup really requires to have a clear view of the entire services. So looking at this from a timeline perspective, for example, really gives you a view of where did you spend the time, where are there gaps, so you can ask questions. And again, when you decide you want to drill down to anything, you can click on it and understand the actual details of that execution. I also mentioned, by the way, the cost. In this case, you see over here, like Lumigo is able to calculate the cost of all the different services, as long as they're serverless services, and tell you how much cents this request costs. With that in mind, I want to come back and summarize. There are we talked about the layers of Kubernetes, the need to monitor all of them if you're doing Kubernetes. Microservices requires distributed tracing. It doesn't matter really if it's Kubernetes, serverless, containers, even VMs. We talked about very briefly OpenTelemetry, Jaeger. Those are things that you should look in case you want to implement your own distributed tracing in containers or microservices environment. That's not taking care of the managed services, but it is a great place to start. And please try that before implementing your own, because everything is ready for use over there. So it would be a shame to reinvent the wheel, and it's a great framework. There are emerging monitoring challenges, especially around distributed tracing in managed services. We talked about that. I showed you how distributed tracing can look like in a managed services environment. So one way or another, aspire when you scale to get to such a visibility. And last, serverless leads to managed distributed tracing, because you cannot get to the level of observability and distributed tracing on your own today just by passing correlation IDs. Again, we talked about the walls and about the S3s that you cannot get across in an easy way. One last thing, by the way, to the audience, if you're interested in trying out Lumigo, feel free to just go to lumigo.io, click start a free account. You get a free tier. You can try, again, it's 10 minutes to connect to the environment and try this out. And if you insert this promotion code, you'll get, instead of the free tier that is 150,000 invocations requests per month, that's our free tier, we'll bump this to 300,000 requests per month. So that's very easy and free to start using, especially if you're small scale, if you're in dev, if you're in staging or private projects. I want to thank you for that. This is Tim Wagner from a serverless conference, Breaking Servers. So I always love to end with that, and that's really inspiring for me. And with that in mind, I want to also invite you to send me any feedback, thoughts, notes, questions. We really love communicating and helping wherever we can. So with that in mind, I'll be happy to answer any questions if you have any. And I will check in the Q&A if we have any questions now.
Yeah, so folks, now's the time while we still have a little bit of time to get those questions in if you have any for Erez. A wonderful presentation, as expected. And Erez, I mean, I guess I'll give one like, kind of allow you to kind of sell the goodies essentially. Like, what's your advantage over your competitors with Lumigu? What makes your platform special?
Yeah, I think this is a great question because there's so much tooling around monitoring and debugging and distributed tracing. Absolutely right, and it's so much. I'm a developer, but so much marketing going around, which is their job. But at the same time, the modern tools and what makes Lumigo different is the ability to go. Lumigo was built for managed services, for serverless. The ability to go across S3, across DynamoDB, across Kinesis, API Gateway, and having this in one click or 5 clicks without any code changes, that's what really sets us apart. And this is why I encourage everybody to try, because it's so easy. And at the same time, if you have a serverless environment, it's so clear, the differences are so clear when you look at the tracing through Lumigo or anything else today.
So you say it comes down to streamline, right? You've kind of got rid of all the bloat and you've tried to make it as user friendly as possible.
Exactly. And you have like the end-to-end from the very beginning to the very end without any disruption or correlating. Absolutely.
Okay. I love that approach. I mean, at the end of the day, right, there's so many new tools all the time. Like each year, it kind of feels like tech becomes obsolete. So you want to actually make it as accessible as possible because, as we know, once you get a few years into software development or whatever your role is, you do become a little bit hard stuck with the past, right? There's
That's right.
practices that we prefer. So I'm
Yeah,
glad to
absolutely.
hear that.
And I think one of the things that we're seeing is that more and more people are trying to figure out what is the best of breed for my use case. And this is, I think, where we see, especially in serverless and Kubernetes now, and more people are asking, like, I want a tool. There are some tools that can do everything, but I really care about this, and I want a tool that is best fit for this. So this is, I think, where a lot of the modern companies, modern application are heading to.
Yeah, and it's definitely commendable because when people come to you and say, I want everything essentially, right? Like you roll your eyes like, oh, everything, what does that even mean? Where do I begin? So yeah, it's great to see you tackling that challenge and making these tools more accessible. It doesn't look like we've got any questions coming through. So I think maybe we'll just round that out. Any final thoughts you want to add in, or the floor's yours for a few more seconds if there's anything. If not, we can wrap it up.
I want to say in the meantime one more thing. I think we're very much focused on serverless and Kubernetes. I think that what we see in the community, and we see the growth of the community, and that's great. At the same time, this these are new domains for everyone. And one of the things that I hear all the time from prospects and customers is we need help to understand how do we attack that, how do we tackle that, because it's new for us. We never done it before. My advice is reach out to the community, because one of the things that I'm really excited about the community is that everybody's so open and everybody looking to help. It's still not everyone in the world is doing that, and there's a great support that we got from the community. So try, we're here to help, but there are many other community heroes, I want to call them, that would love, just send them a direct message on Twitter or tweet, and they would help you. That's as simple as that.
Yeah, I love that collaborative element, right? Like not kind of gatekeeping or keeping people out, but always trying to like further, the pursuit of tech. It looks like we actually did get a question in from Milan. He's asked, in relation to AWS, I overheard mention of the AWS X-Ray. What are further benefits of Lumigu compared to X-Ray?
That's a great question. I didn't mention X-ray just because I didn't want to get into specific tools. But if you ask this question, let me go back and share something that I think will show the differences. 1 second. Yeah. So going back to this, again, this is, and that's a differentiator with X-ray and with any other existing tool. When you try to run X-ray on such an environment, even if everything is AWS services, and it's kind of surprising, you will still get most of the services disconnected, just because X-ray haven't been able to, to support the main AWS services. So in Lumigo, you'll see this, and in X-ray, you see like a variation of this. I think they support one or two of the services, but definitely not the main services. So it really boils down to this. For example, X-ray can do this, Lambda, DynamoDB, Lambda. Can do this, Lambda, Event Bridge, Lambda. So this will be missing from the picture and will be disconnected. And the connectivity, the correlation is what it's all about. So that's one point. The second point is that X-ray requires a lot of code. You need to code, you need to change, you need to add it to your environment and understand what you're doing, and then get the correlation idea across. That's, in Omega, it's one click, no code changes. And I would say that's the second thing. It's and the main one is the full visibility.
Okay, that answers that pretty well. Peter's just asking quickly if the trial coupon could be posted in the chat. So if you got the trial coupon,
Yes,
feel free to
absolutely.
throw it across them.
So I will pause it. I will just say that we have it's not a trial; it's a free tier. So it's free. We have a free tier, free forever, up to 150,000 invocations per month. If you have that, just join, use. You don't need to talk to anyone. It's free, and it's a community support. But again, for the audience, I'm posting in the chat now. Sorry, in the chat, the promotion code that will allow you to bump this to 300,000 invocation for the first year, just because you're a part of the conference.
Awesome. Well, I mean, there you go, folks. An easy to use tool, easily accessible one, and also now giving you better access for free by doubling up the free amount of rotations you get. But folks, I think we'll bring this to a close. It's about time to wrap up this session. So thank you again for speaking for us, Erez. But we have one more speaker today, and they will appear after a short break. When we return, we'll be getting into our keynote. Our second keynote of the day is going to be why Agile 2 ideas help organizations to use DevOps. You don't want to miss